Hello kids, let's start with the chapter HCF and LCM, and this chapter is not present in the Ganit Prakash or in the RS Aggarwal. This content has been taken from the previous year's book. Okay, so let us start with HCF and LCM. Now, before we begin to solve the questions on HCF and LCM, first of all, let us understand what is HCF and what is LCM. So I'm writing here HCF is the highest common factor. Highest common factor. That is that one factor which is highest among the numbers of which we have to find the factors. Okay, of which we have to find the HCF. So I'm taking one example. Here I am taking the example of, let's say this is 24 and 32. Let's take another example. I am taking 12 and I'm taking 18 here. Okay, so what we have to do here is we have to find their HCF. So for that, first of all, I'm going to write down all the factors of 12. And what are the factors? We have already done in the prime time chapter. Factors are the numbers which divide the given number completely. It doesn't leave any remainder. Okay, so the very first factor is 1. Then we have 2 also. 2 divides the 12 completely. 3 also, it also divides the 12 completely. 4 is also a factor. 6 is also a factor. And after 6, what we have is 12. Okay, so these are the factors of the number 12. Now coming to number 18, let's write the factors of 18. We have 1, 2, 3 is also a factor, 6 is also a factor, and then 9 is also a factor. The last one is 18 here. So these are the factors of the number 18. Now we have to find the HCF. We can also write this as, we can also write in this notation that we have to find the HCF of 12 and 18. Okay, so now what we have to do is we have to find the highest common factor. So if you see here kids, first of all let's mark the common factors. Okay, so what are the common factors? 1, it is present in both. 2 is there, 3 is there, and 6 is there. Okay, these are the common factors. I am writing CF here. The common factors are 1, 2, 3 and 6. These are the common factors, and what we have to find is the highest common factor. Highest common factor is the highest number in these. What is the highest number in these kids? It is 6. Okay, so the HCF of 12 and 18 is 6. Okay, so what we have done, we have written all the factors of 12 first, then we have written the factors of 18. Okay, we have written all the factors of both the numbers, then we have find out the common factors, that what are the common factors in these two numbers, and among those factors which one is the highest. So the highest one is called as the HCF, that is the highest common factor. Okay, so now let's come to the book. Highest common factor, the greatest number which is a common factor of the two or more given numbers. So kids, here we are taking the HCF of two numbers, but it might be possible that we are being asked to find out the HCF of more numbers, 3 numbers, 4 numbers and so on. Okay, this is called as the highest common factor or the greatest common divisor also. We also called HCF is greatest common divisor or greatest common measure, and we can denote it with HCF for highest common factor. For greatest common divisor we have GCD, and for greatest common measure we have GCM, but the most commonly used is HCF or GCD. Okay, we have to keep this thing in our mind because there might be a scenario where we are not provided with the information that you have to find the HCF. You might have been asked that you have to find the greatest common divisor or what is the greatest common measure. Okay, so keep these 3 things in mind. Now coming to the example given here, let us find the HCF of 24 and 32. So what we have to do, again we have to, I'm taking the example here. This is the HCF of 24 and 32. So let's begin with this. First of all, we will write down all the factors of 24. So first 1, that is the factor always. Then 2 is also a factor. 3 is also a factor of this. 4 is also a factor. 6 is also a factor, right? Then 8 is also a factor of this. Then coming next, 9 is not a factor, 10 is not a factor, not 11, 12. 12 is also a factor of this. Okay, and then after 12, the next factor is 24 itself. These are the factors of 24. Now let us find out the factors of 32. Again, it is 1 here, 2 is a factor, 3 is not a factor, 4 is the factor, 6 is not a factor, 5 is not a factor, 6 is not a factor, then 7 is also not a factor, 8 is a factor, right? 8 is a factor of this, 9 is also not a factor of this, not 10, not 11, not 12 also. Okay, then the next factor is 16. 16 is a factor, and after 16 straight away we have 32. So these are the factors of 32. These number divide the number 32 completely. Now what we have to do next? Find the common factors. They are 1, 2, 4, 8. Okay, so these are the common factors 1, 2, 4 and 8. And out of this, what we have to do? We have to find the highest factor, highest common factor. The highest number is 8 here. So 8 is the HCF or the highest common factor, and same has been written here also. Okay, so now we know that how we have to find out the factor, the HCF, using the common factor method. Okay, this can also be called as the common factor method. But now kids, in our syllabus, what we have to do is we have to use the prime factorization method. Okay, so we have to use this prime factorization method to find out the factors. Okay, so let's see how we have to do it. We know what is prime factorization, right? We have to find all the factors of the number till it goes to, and we have to drill it down to the lowest point till we get the last numbers, the last prime numbers. So what is written here is, to find the HCF using the prime factorization, we first find the prime factorization of the given numbers. So what they have done here is, two numbers are given to us separately, we have to do their prime factorization first. Using prime factorization, we can obtain all the factors, we can find all the factors, then the product of all the common prime factors using the least power of each common prime factor is the HCF of the given numbers. Okay, let me explain to you and then we will do the examples also. Let's take the given example only. So what we have to do, using, I'm writing here, using prime factorization. Prime factorization method. So what we have to do here, kids, first of all, we have two numbers, 144 and 198. So for prime factorization, we have to find out the prime factors of both the numbers individually. So for 144, how we can do this? 2, 7, 2 into 7 will give us 14, and then 2 again here. Again we will divide 72 by 2, we will get 36. Then 36 with 2 we will get 18. We will get 9 here, 3 and 3 again. All these are the factors of 144, and they are prime factors because they cannot drill down further. Okay, and now what we have to do, same for 198. How we are going to find it? This is 2, 9 and 9, then 3 into 33 will give us this, then 3 into 11 will give us 33, and 11 into 1. Okay, so all these are the prime factors. We cannot drill down these factors further. Okay, so let me write down here. For 144, we have 2 into 2 into 2 into 2. This is 1, 2, 3, 4 times 2 and 2 times 3. Okay. So now kids, how we can write these numbers in the form of powers. What we have to do here is we have to use the least power method. So before that, we should know what is power. This we have already done in our chapter first, right? But again, I'm going to tell you here, example I'm taking quickly. 2 into 2 into 2 into 2, we can express this as 2 raised to the power 4. 2 raised to the power 4 means we have to multiply 2 4 times. Okay. And if I have 2 raised to the power 3, that means we have to multiply 2 3 times. If I have 3 raised to the power 5, that means I have to multiply 3 5 times, right? This one is called as the base and this is called as the power. Base is the one which we have to keep on multiplying for the number of times the power is given to us. Okay. One more example I'm writing. If I have 7 raised to the power 2. So my base is 7. I will write 7 and then I will see how many times I have to repeat this 7 here. Okay. For 7 raised to the power 2, this is 7 because it is present in the base. I will write it. I will write it like this and then raised to the power 2. That means 2 times. So this is the base, this is the power, and we say it as 7 raised to the power 2, 3 raised to the power 4, 2 raised to the power 3 and 2 raised to the power 4. Okay, so we have already covered this in chapter 1 also, but we are going to use it here also. Okay, so let's see how we are going to use it here. I am just erasing this part now and let us proceed with our question again. So now I can express these number as power also. I have 4 times 2, so I can write this as 2 raised to the power 4, right? And 2 times 3, 3 raised to the power 2. This is how in the form of powers I can express the factors of 144. This is done. Now let us come to the another number 198. What are the factors of 198? They are 2 multiplied by 3. We have 2 into 3 into 3 into 11. Okay. So now I can write down 2 as is. 3 I can write down 3 raised to the power 2 because 3 is 2 times here and then 11 as is. Okay. So now what I have done, I have expressed these numbers, these factors in the term of their power. Now, for finding out the HCF using the prime factorization, what we have to do is, we have to, I'm writing here, we have to use the least power. This is important. We have to use the least power of each common prime factor. Prime factor. So let us break it into steps. First of all, what we have to do is we have to find the common prime factor. All these numbers are prime. Let us find out the common numbers first. Common prime factors. 2 is here and 2 is here also. That means I am marking it. 2 is our common factor. 3 is here, 3 is here also. 3 is also our common prime factor. 11 is not present. So what are our common prime factors? 2 and 3. Next, what we have to do is we have to find the least power of each common prime factor. So what is the least power of 2 here? The least power of 2 is 1 because here the power is 1. If there is nothing written here, that means it is 1, right? We have done this. So this is 2 raised to the power 1. This is 2 raised to the power 4. So the least power is 2 raised to the power 1, which is 2 itself. Still I am writing 2 raised to the power 1. And then for the another number, We have 3 raised to the power 2 here and here as well. So we will take the same. That means our least power of each common factor is 2 raised to the power 1 and 3 raised to the power 2 here. Okay. And now what we have to do, we have to find their product. I can write this as 2 and this is 3 raised to the power 2 is 3 multiplied by 3, that is 9. So answer is 18. Okay, so our HCF of the given numbers 144, 198 is 18 using the prime factorization method. So I am repeating this again for you. What we have done, first of all, we are provided with two numbers, okay, and we will find their prime factors individually. We have find out the prime factors of 144 and 198 and we have written it as is. And now we have converted it in the form of the powers if possible. So here for 144, 2 is repeated 4 times. So I have written 2 raised to the power 4 and 3 is repeated 2 times. So 3 raised to the power 2. Now for 198, same thing, 2 is 1 time only and then 2 raised to the power 1 is here. For 3 it is 2 times, so 3 raised to the power 2 and 11 as is. Now for HCF using the prime factorization, the rule here is we have to use the least power of each common prime factor. So we have to find the prime factor first, that were 2 and 3 which is present in both of these and the least power of them. So the least power of 2 is 1 here. So we have taken 2 raised to the power 1 and the least power of 3 is 2 here only because in both the cases it is same. So I have taken the same number. Okay. So now what we have to do is we have to multiply them to get the HCF. So this is how we have to do this question. Now kids, I will explain you the next question here itself. What we have done here is we have to find out the HCF of 396. We have to find out the HCF of 396 and 1080. We have find out their prime factors first. So this is, we have to divide 396 with 2. We'll get 198. Then with 2, this is 2 into 9 is 18 and again 18. Here 3 into 3 is 9, 3 into 3 is 9, so we have got 33. Then 3 into 11 will give us 33. So this method we can get the prime factors. These all are the prime factors of 396. Similarly for 1080. So we'll start with 2, we will divide 1080 with 2. This is 2 into 5 is 10, 2 into 4 is 8 and 0 as is. And then we will keep it on dividing. So till here we can divide it using 2 and then this is 135. That means we have to divide it with 5 now. Okay. So this is 5 multiplied by 27 will give us 135. Then 3 into 9 will give us 27. And again 3 into 3 is 9. So on. So these all are the prime factors of 1080. And next what we have done is they have expressed it in one time only. But what you can do here is you can just write down 396, the factors of 396 as 2 multiplied by 2, 3 into 3 into 11 for your ease first. And then for 1080, we have 1, 2, 3. 1, 2, 3 times 2, then 5 into 3 times 3. Now we can express it into power. This is 2 raised to the power 2 here, 3 raised to the power 2 here and 11 as is. Okay. And for 1080, this is 2 raised to the power 3. This is 3 raised to the power 3 and this is 5 as is. Okay. And these all are their factors in the form of powers. What is our next step? What we have to do is we have to find the least common powers. So coming to 2, here we have 2 raised to the power 2 and here we have 2 raised to the power 3. So what is the least power? 2 raised to the power 2, right? And then in the next one we have 3 raised to the power 3 here, but in the other one we have 3 raised to the power 3. So what is least power? 3 raised to the power 2. So we will take 3 raised to the power 2 here. So these are the two things which are common. If you will solve this, we will get 4 into 9, which makes it 36. Okay, so this is our answer. So kids, I hope that you have understood this And now this is called as the HCF using the prime factorization method.